Okay, David is going to start, and we're going to swap back and forth. But I think we'd be happy to do questions as we go through, rather than waiting for the end when people may have forgotten their question or so forth. So if the question is something that we're going to cover, then we might defer it until we get to it in the slides. But please do jump in and ask questions as we go. Okay, David, go for it.
And can everyone hear me okay?
Yes.
Yes.
Yes. As today we're mostly interested in talking through the model which we have been developing for the American Art Collaborative and extensions beyond what we're doing for AAC. But I thought it might be helpful to give us a little bit of background on the terms that we're using and how they relate to each other. And the main terms we talk about a lot when we're talking about this are the CDOC CRM, RDF, and linked data. And these are three concepts that we throw around, and I don't know that we often distinguish between them well enough for people who aren't experts. So I figured I would just explain quickly what the three of them are and how they're useful for what we're doing. Next slide. So starting with what is the CDOC CRM? And from their website, the CDOC CRM provides definitions and a formal structure for describing the implicit and explicit concepts and relationships used in cultural heritage documentation. And so what it is it's an event-based way to look at the world. It's a conceptual reference model, which is what the CRM at the end of it stands for. And it's a standardized meaning and structure for information. It's not explicitly a computer-based thing at all. There are many, many different ways to think about the way that cultural heritage coexists in a world. And what they've done well over the past 10 or 15 years, is to codify a particular viewpoint as to how cultural heritage information relates to itself. And they've done it through the lens of events, which is different than some of the cataloging things, which have done it through the lens of objects or history. It does it through a series of events that link things together. And it's designed to be glue between different sources. So it's this idea that I've got information represented one way, you've got information represented another way. If we all look at it through the same lens, we can begin to see where information comes together. It's coming out of a theoretical academic mindset based around formal logic so that you can prove well what it is. And what it's done is it's provided us a wonderful set of concepts that we can all share in understanding what they mean. So it's really the concept behind what we're doing. The next slide. Related to it is this idea of RDF. And RDF, from its website, says RDF is a standard model for data exchange on the web. And what RDF is a way for computers to work with facts, sort of a high-level understanding of humans are used to working with facts. We need a way that computers can work with facts, that is flexible enough to work with facts in lots of different ways, and to say that fundamentally when we're talking about a fact, we're making a statement about a resource. And so we're going to create the low-level technical framework for doing that in a way that is computer-friendly. This is very, very sort of high or low-level computer science-y. We're going to way to talk about this. So it's not directly applicable to CDOC CRM, but they're related enough in that they both talk about this statements about resources model enough that they can often be used together. And it, we've talked about this subject, predicate, object lots of times throughout this whole thing, and that's really what RDF is it says we can express facts as a subject, a predicate, and an object, and this is a technical set of tools to do that. Next slide. And linked data is what we actually talk about. And linked data is a way to say, okay, RDF is really useful, but it's flexible enough that you can do all kinds of things with it. And so what we want to do is say, let's take that and let's say, rather than say you can do everything with it, let's narrow down what you can actually do with it to make it easier for people to know how to actually do. And so there are rules that make RDF useful for people. And we say, okay, each one of these subjects, predicates, and objects should have an ID, which RDF says. But we say that RDF, that ID should be a web URL, an HTTP URL. And when you put that URL into a web browser, it comes back with information about the thing that it's describing. And it also says that whenever possible, you should use URLs that other people have provided, not just the ones you've created. And that creates this idea of linked data. So it works on the web. It provides us with rules about what those URLs should look like and what should happen when you access them. And it also says that it should be natively collaborative. And so when we're talking about a linked data model, we're saying we're going to take the CDUC CRM, which is this conceptual model that works as logic, and we're going to represent it using linked data. So we're going to say, take these two concepts that are both very useful ways to talk about data and combine them into something that is useful for what we're doing. Next slide. And we're not the first people to do this, obviously. The CDUC CRM linked data model, the British Museum did a bunch of this, YCBA has done this, SAN's done this, Getty has done this, lots of other people have done this. And in doing this, our work, we didn't do it in a vacuum. We looked at all of the work that these people were doing, and they were important in that they were primarily publishing focused. They were interested in taking the data and getting it out for the public as part of the mission of the institution. And they did it often with the best knowledge of their systems that they had, all the nuances of what makes their data special and interesting. And they would often define things that worked for them. And they were focused on semantic correction, which means they wanted to make sure that the information and the knowledge that they had and had represented was as correct as possible, which is a really important thing to do and an important part of doing. Next slide. And there's a question from Kate, which says that it might be useful to know if RDF is the same as JSON or it's something different. RDF is, when we talk about RDF, it's sort of at that level of database, not at the level of MySQL. And I think of JSON and XML as representation of information as, you know, words on a computer screen. RDF is more about the mechanisms behind that. And Rob might be able to clarify that more.
Yeah, I'll have a go quickly. So the way that I think about RDF is that it's a framework based around the notion of graphs rather than trees, into which you can put data and manage data. But once you have it in that framework, you can get it out of it again in different serializations, including JSON, being JSON LD, or XML, RDF XML, or Turtle, or other sort of more specific serializations of that model. So RDF is sort of the in-memory system, or the back-end database system, and then JSON LD or RDF XML is a way to essentially record the information that's in memory such that you can transfer it between systems so that they can then get it into their database or read it into memory. Hope that helps.
And the reason we have to do that is, if you think about a graph, or you think about museum data, everything is connected to lots of other things. But when we write it down, we have to write it down in an order. But we have to sort of say, okay, what order are we going to write these all down? And there's no by default correct order because nothing comes after anything else. And so all of these serializations are ways to take our multidimensional, complicated data and write it down in an order that is less complicated. So we have to keep a bunch of rules as to how to put that complexity back. So when we talk about serializing it as JSON LD or serializing it as turtle, it's writing down something that you can't put on a piece of paper using rules that encode a bunch of that extra complexity. Going back to the slides. When we sat down to work on the AAC target model, what we realized is that in order for the AAC to be successful, we couldn't just duplicate what other institutions had done because ours had to work across many institutions. We couldn't do what was best for each institution and hope they work together because each institution is different. And in particular, they had different levels of completeness. So some institutions go very deep into dimension, others have a written description of it. Some institutions go really deep into materials and others don't, some into subjects. And you all know, what your institution focuses on and what it has not yet focused on. And so we had to make it work at all these different levels, and so we couldn't encode those practices into it because it wouldn't necessarily work for every institution. So it's how do we make it more general? And it helped that we had lots of examples from the other institutions as to ways that they had focused on things that they were good at. The other thing is because we have to build the browse application on top of this, and our hope is that other people will build other things on top of this, we had to care a lot about what I call round trip ability, which is that the data that you express has to be accurate. So we need that semantic correctness. We can't throw away the knowledge that you have represented. We have to say that once you put that knowledge in, it also has to be able to come out. So it is correct to say that, the title of a work is a kind of name for it. And it's also correct to say that the accession number is a kind of name for it. They're both identifiers for it, one as a title and one as an identifier. But in order for us to pull back the accession number, we have to distinguish between those different types of names for a thing. And so that when we talk about round trip ability, it's not enough to be correct. It has to be correct, but also uniquely correct. There has to be a way to ask a question that gets that data back. And that's one of the things that we learned as we started trying to build the browse applications. We had to really focus on that aspect of it. The other thing that we've been doing is saying that because we want this to work in a world where it's not just our institution, but these links across many institutions, we're using the C.CRM as an ontology, but we're also using other RDF vocabulary like AAC. So we're doing that linked data pointing to other people and other best practices in the RDF world. Because we have that flexibility because we are using both RDF and linked data and the C.CRM at the same time. And our interest here is in usability. We don't want to get rid of semantic correctness. We don't want to be incorrect. But we want to make sure that primarily this data is as usable as possible after it's been published. Next slide. And so what we're talking about is AAC and its ongoing work, which we're calling linked art, which is patterns and models that enable cultural heritage institutions to easily publish data for both event-based digital research projects and for non-cultural heritage developers. Because as we've been looking at this and related projects and identifying who wants to use this data, it's primarily large-scale research projects that want to aggregate museum data. And so they want lots and lots of information that they can combine with lots of other information and do new research on. And the other people are developers who want to build interesting applications on top of this, but may not have enough either semantic web understanding or cultural heritage information and understanding to use it at its full complexity. So we have to make it easy for them to know just enough in partnership with you guys to build things on top of it. So we have to use their language as well. And what we've realized is that we can probably get 90% of the things that people want to do for about 90% of the organizations, but we don't need to use all the complexity that CRM provides. There are always going to be edge cases that we could do, and what we're saying is let's focus on the useful 90% right now and try to make that complexity of the CRM, which allows us to do incredibly complicated, useful things. But let's do these simple, important parts that are fundamental to our field. And then once we've got that understood and well-defined, then we can look at additional complexity.
So the way that we've been thinking about this notion of usability is about the sort of target audience or the driver for the particular phase of work. So you can imagine that you've got the pointy-head boss there who is cranking away on the machine that, from his perspective, is turning money into these things called triples, which then get thrown over to someone else to use. And from that perspective, it's important to be complete, where there's, as our new head of information systems says, no data left behind. That we need to be able to model all of the important stuff, and as David says, to have it round trip so that once you put it in, you can also get it back out. But then those triples have to be used for them to be valuable. It's not just an academic publishing exercise. So the poor developer there in the middle, frantically hacking away on his laptop, wants those triples, wants the information to be usable, because he needs to do something with it, either turn it into an application or provide information to researchers, merge information between data sets, and so forth. So say he then produces some web application like the browser app, then people using it, such as researchers, want the information to be accurate, right? Because if they are looking at a bunch of different sites and drawing conclusions, their conclusions are only going to be as accurate as the information that they're using. So for the purposes of our work, the accuracy isn't as fundamental to the design, because that comes from the underlying data sources. That's from all of your collection management systems and so forth, which you've all done, many decades often of work on. So we don't really need to worry about that so much. And then there's this balance between completeness and usability. So as you start to add information into any system, it goes from being 0% complete and hence 0% usable because there's nothing there, and it quickly becomes usable with only a bit of information, right? You can get by and do quite a lot of stuff with only the basics. Then there's this sort of long curve of adding more information, and you get a little bit more usability, and you also get more completeness. But after a while, as you add more information, the usability collapses back down to 0. So you might have absolutely every single piece of knowledge that anyone knows about a single object, but there's no way that anyone could use that because they'd be just overloaded with the content. So there's a target zone that we're trying to get within in terms of the model of what it should be representing. So we're not aiming for 100% completeness. We're not aiming for 100% usability either. We're trying to essentially maximize the area under that graph. Right? So you don't want it to be 0, 0. You don't want it to be 100, 0, because that would be 0. You want it to be somewhere in that top right-hand quadrant. So that's our thinking. That's our sort of internal design principle for how the model is being built out. So we looked then at what data models have been successful and what they did so that we can learn from those previous successes and not repeat past mistakes. So we found that successful data models are ones that solve actual challenges rather than just being very theoretical, and while they might model reality very accurately, if that model doesn't solve some problem, no one is going to invest the resources in implementing it. And those challenges can then be documented as use cases, either in a sort of standardized form of, as a researcher or as some user, I want to do something because some reason. Or they could be just documented as, it would be great if we could do X. But those use cases are important because they give us that way of determining the 90% of problems that different institutions share, so that we know where to focus. Also, importantly, it has to be able to be built using data that's already captured and available. Right? None of this work is about producing new descriptions or producing tools that allow you to create better descriptions. It's taking the content that you have in your collection management systems and making it available in a way that's shared and consistent. So that's then the second point there, that they allow consistent description of shared use cases. But if we simply took SciDoc CRM and gave it to all 15 different institutions and said, go off and use this to describe your use cases, there would be 15 at least different ways of doing that. So the importance for interoperability and hence for use is that we come to agreement, come to consensus around how we can all describe our shared use cases. Beyond that, it's important to allow additional information that isn't shared to be captured and published, but without getting in the way of the consistent description. So that if someone comes to the description that you've published and you've added a bunch of extra stuff, they should be able to ignore it and just use what they know to do what they want to do. It needs to be able to be productively used. So it should be easy to implement applications or services or tools using it. And it should be easy to publish the data. It should be easy to implement services that provide access to that content. And once you've got those three, of course, you can then provide interoperability with other data, such as the Getty vocabularies, but also information in Wikidata, DBpedia, or elsewhere in the linked open data cloud. So that's sort of the features of a successful data model. We also looked at how, or the process by which data models are successfully built. We found that they're built iteratively. So we know that we're not going to get this right the first time. We're probably not going to get it right the second time or the third time. Right? We're going to go back and reevaluate what we've done in the past, given new information and new use cases. So things are going to change. That's the only certainty. So it's a case of being also responsive then in that iterative process, that we're not just going to change it willy-nilly, we're going to adapt it in response to feedback and in response to new use cases being provided. And we'll also do it responsibly as well as responsively, in that we'll consider the changes and features carefully, Is this something that needs to be added? Is it really a shared use case, or is this something that could be handled in that 10% of institution-specific information? And of course, successful data models are developed collaboratively. So throughout the process, we've tried to engage with the community, both yourselves and the AAC, but also other stakeholders around the cultural heritage domain. They're also carefully bounded with respect to scope. So some of the things that we thought, at least for now, are out of scope to prevent sort of disappearing down rabbit holes were complex bibliographies. And for that, we figure that the library domain is working on BibFrame and other linked data patterns. So we can simply adopt whatever solution they come up with, assuming that it's reasonable. It might be that it isn't, and that we need to do the work ourselves, but hopefully not. Data provenance, so not provenance information about the objects, but provenance about the data itself. So how did it change? Where did it come from? Which systems did it come from, and so forth. So this isn't a museum-specific issue. There's a bunch of different solutions in the linked open data domain for solving that, and we should simply choose and adopt one. And finally, the quantification of uncertainty, by which I mean that for all historical information, there's always uncertainty around it. Some things we are very certain of, and some things we can guess at. And we don't want to try to quantify any of that range between this is a guess versus this is certain. And it's really up to the individual organizations as to what they feel comfortable with publishing, whether they feel comfortable saying, publishing an assertion that an object is, say a painting was painted by Rembrandt, even if they're not absolutely certain, versus another organization that might feel less comfortable with that uncertainty and not want to publish it. And there are two issues here. It's unsustainably complex to do that. Adding uncertainty to any given assertion makes the data almost entirely unusable. And also the data for that information is normally not available in the underlying databases, that while the humans might know, oh yeah, we're not really certain about that, or we know that if we put square brackets, question marks, square brackets, that means that we're reasonably certain, but there is some doubt. Right? There's no comprehensive, sustainable way of managing that information. Successful data models focus on the primary sources of concern for the domain. So for us, there are three core classes: the objects that we manage and love, the people who are involved somehow with those objects, and in between them, the activities or events that the people carry out using those objects or somehow to do with those objects. So I'll come back to, or David will, come back to those three classes. But there's one more point about successful data models, which is that they are consistent and unsurprising. So whenever you see a new feature in the model, it should be something that seems familiar already. It shouldn't be a surprise as to why that particular design was chosen. So we also have three primary common patterns that we identified and have tried to use consistently, being classification as a way of being more specific, primarily using AAT. The partitioning of resources into parts. So an object can have parts, but also activities can have parts. So if you think of an object being created, there were 3 different artists involved in the creation with different roles. Instead of trying to collapse all of the artists' roles into the top level activity, instead we partition the creation into their individual roles within that larger activity. And as David was saying earlier, statements about resources. So this is the area where there will be textual information intended for consumption by humans, such as material statements or dimension statements, some of which may also be available in a machine readable form, such as it's this particular material or it's this particular dimension. But we need that way of being consistent about statements, regardless of what the statement is actually semantically about. David, was I going to do this, or were you going to do these ones?
I think you're going to take these 3 diagrams, and I'm going to pick up after that.
Okay. Okay. So to go through those 3 classes just briefly. So for objects, we identified 5 areas of information. Identity is of course critical. We need to know the identifiers that are used, so session numbers and previous identifiers and so forth. Classification, so is it a painting or is it a sculpture? And labels, so what appellations, what titles, what labels have been used for that object. Digital integration, so which images are available online, what are the web pages that are available about the object, and what services, such as the palette of colors that are used in the painting might be available. Physical information, of course, what are the materials or dimensions we've talked about already, and what parts make up the whole object. So a triptych, for example, would have 3 different panels with 3 different sections, each of which might have further parts below those to distinguish, say, the frame of the segment from the panel that is painted. There's interpretive information, so descriptions and other statements about the object. What does the object depict if it's a painting or similar? What subjects does it evoke? And what style or genre is it part of? And finally, for objects rights information is critical. So who should be attributed? What license is this object usable under, or the information about the object? And what copyright is held over the object. So in terms of being consistency, we tried to keep things as consistent as possible. So for people, identity is also important. Identifiers, classifications, and labels. People have identifiers, people are classified into different roles or under different headings. And people have names or labels. Interpretive, there's less sort of interpretive information normally available about people, but you'd have biographies or descriptions and similar in that space. There are images of people, web pages about people, services to interact with that information, so that's exactly the same. Then instead of the physical characteristics of people, which typically we're less interested in, it's more the membership of the person in sets of people or groups of people. So what nationality is the person, and by which we use this person is a member of the group of British people, or what organizations are they part of. I am a member of the Getty Trust. So gender, not to open the political can of worms, but we treat gender in the same way, that you can be a a member of the group of male people or female people or both or neither or something else entirely. Then finally for people, there is their participation in activities that are sort of about the person rather than about objects. So when they were born, when they died, what professional activities, were they married, and so forth. So then to get back to activity, we've already seen the first three of this. So activities then are carried out by people or groups. They're typically carried out on or using objects. They also occur at certain times, which is quite easy. It's very quick to end up at dates. So there wasn't much need to talk about how time works in the model. And they occur at places. So for places, we also defer to external gazetteers. We don't want to try to model all of the information that's in TGN or geonames or who's on first or similar. We just want to be able to point to it happened at this place and then allow those external systems to give us more information about how that place fits into the world. So yeah, again, as David said, activity is really central to the model. Things occur, activities occur on things, they're carried out by people, they occur at a particular point in time, and they occur at a location in space.
And so that is very much the CDOC model, and the parts of it that we are primarily concerned with in museum cultural heritage information. These are patterns that we are using to handle common cases that we see. One of which is this classification of specific. And this comes back to that round trip ability problem we have. CDOC CRM calls out certain types of things. It says titles are different than identifiers, or people's names are different than titles. These are all different types of appellations, but as we started looking at your data, we realized that in reality, there are hundreds of different kinds of names. And so what we've learned is that we are using the AAT to say, rather than create a new type of thing for every possible type of name, or every type of organization, or every type of activity, or every role someone could play, we say, in the CDOC CRM, we will choose a generic thing. And for names, CDOC CRM calls them appellations. And then it will say, this appellation is of the type, this AAT term. And what that does is that gives us a really nice way to use the many, many classes of things that AAT has to talk about the many, many classes of things in the world. And AAT works very hard to provide names for all sorts of art historical things and is much more comprehensive than the CDOC is or should be. And for our model, we are using AAT because it is such a wonderful resource for what we do. But this pattern is something that we could use. If there are concepts that we want to talk about that AAT does not cover, if we can find a vocabulary that exhaustively defines that concept, let's just say, this is a type of that. For instance, AAT, to my knowledge, doesn't go into the specifics of artistic genres or styles, or iconography. Let's take iconography. Currently, I don't think AAT does iconography, and Joan, don't correct me if I'm wrong right now, but say icon class does. We could say, rather than try to do CDOC CRM, we should use that linked data principle of pointing to other people and point to the icon class words for all of those things.
And I do want to, Patricia is working on a 5th vocabulary in iconography to cover things that the icon class does not cover. They can coexist. but it's a good distinction. But genres, I think she does intend to include, so it should be contributed.
But it is that idea that what we are doing is finding experts in the world and pointing to their classifications, because that CDOC CRM nor LINC nor the AAC should try to exhaustively define every term possible. And this also lets us use your individual classifications when there aren't external authors. We pull your classification list and use those as the text. Next slide. The other thing we do is we do a lot of this partitioning. And one thing we've learned from this data and also other work is that everything can be broken down more and more granular. You have a museum, but your museum is made up of departments, and your departments have individual programs, and the programs have sub-programs. And it is possible to go as deep as necessary to capture the nuance that you need, but we don't need different names for all of those things, and having them represented as parts can be really helpful. You know, objects, we have a painting, but that painting is made up of a frame and a panel. And that panel is made up of support, and then paint, and then glaze, and then overpainting. And we can go as deep as we want. The glaze is made up of binders and pigments. And so rather than try to treat everything at possible levels of granularity, we say, this is something that can be done in a pattern that we should recognize, but we don't need to always go as deep as necessary. We should leave that as an option, but often in this usable world, what I don't want to do is have to try to describe a painting by looking at every possible pigment it's made up of and go back up to that. It's useful to think of it as a high-level concept that is made up of lots. And each institution will go deeper or not deeper based on where their expertise and where their data is good. But by keeping them as parts, we let us users have a consistent view of the world, that they can dig as deep as they need to. Next. And finally, one of the patterns that we see regularly is that occasionally often there's machine readable data about something, but often there's only written descriptions of things, and these are not the same thing. And often you need both of them in conjunction, because there's always data that you have written out for people that the knowledge there cannot be fully modeled, or we haven't done the work to fully model it. In our databases, you know, you all know that I've been working on Archives, which has been trying to dig as deep as possible into provenance. There should be a parallel effort in materials and what are paintings needed, how are works attributed, what are the bibliographies of people. Having both the text and the machine readable data, and knowing that they can go back and forth, and knowing also that when institutions have not got to the point where they have represented the data about, say, the dimensions of their work at as granular a level as we can, that data is still valuable and should be provided, even if we can't use it for a computer, it's still useful for humans. And when we think about usability, that's important, is that sometimes it's really useful to be able to calculate or compute on data. But even if we can't do that, it's useful to be able to have a human read it and understand it. And so understanding that these are two different things and that they aren't replacements for each other has been really helpful, because then it means we don't always have to go and parse your description, parse your text, break it into pieces and put it in the individual fields. It's also useful just to capture those words that you've said about it. Next slide. And so the other thing that we've been doing is we've been working on representing this as JSON LD. And again, RDF is a in-memory computer data model. But what we said is that we should not get rid of that complexity, but we should represent it in JSON LD, which is a form of JSON that encodes all of that graphy data. But the other benefit that it lets us do is it lets us use words here to describe the CDOC CRM classes that make sense for developers. We haven't lost the fact that when we say classify as, what we're really saying is has the predicate CDOC-CRM P3 as type. But we use a phrase that has meaning to developers who, in my experience, being one, are often too lazy to go look up the documentation until they need to. And so what we're trying to do is find words that express all of these art history concepts in ways that developers will have an intuitive understanding of what it means. And JSON-LD is really nice because it lets us use simple words when we can, but not lose that semantic complexity and that wonderful, rich ontologies that the CDOC-CRM provides. Next slide. Is this where you pick up again, Rob?
Yes, sorry, I was talking into my muted computer. So yeah, that was quite a, you might be surprised to hear, quick run through of the sort of high level of details of the model. There is much more information about exactly how all of those identifiers and labels and parts and materials and so on are actually described at the linked art site, so linked.art/model. It's split up into sections based on the sort of objects or activities of interest. So there's objects and collections of objects, people and places, the provenance of objects and the exhibitions that they were shown at, and then some more sort of meta information about information around the data set as a whole, and how to refer to the sources, so sort of primary source literature of where that information came from. And not all of that is completely built out yet. In particular, sources and data sets aren't available, and places, I believe, is very skeletal. But the core stuff of objects, people, provenance, and exhibitions are all done. So there's sort of essentially one more question, which is, what's the difference between linked art and the AAC target model? So the linked art model is the iterative and collaborative part of where the AAC target model started. So essentially we want to apply the lessons learned from trying to use and apply the model to different data sets and domains. So here at the Getty, for example, we're working on the provenance index and at Carnegie Mellon at the the Carnegie Museum of Art on artifacts. So while provenance hasn't been a great focus in AAC, it should still fit in with this model. There's also the Pharos Consortium, which is looking at photographic archives of art and how that can also fit in with the model. It provides more detail than the AAC target model could, based on questions from the review cycle and then subsequent AAC discussion. And it provides a mechanism beyond the scope of the AAC project for support and engagement with the community, such as with Pharos or the provenance work, or related projects such as Numisma, which is linked data for ancient coins. So yeah, the target model we needed to freeze at a certain point so that ISI could do their mapping and transformation work. The linked art model sort of keeps that work going without, I don't believe there have been many changes, and the changes that were made are only quite minor. A few tweaks here and there, thankfully. So with that, thank you all very much for your attention, and we'd be very happy to discuss any thoughts or questions or ideas that you might have, or to look at the linked art website to familiarize you with where to go for things, based on how much time we have left, which is not a lot, or priorities. So, thank you.
Well, Rob, first of all, this is Eleanor. I just wanted to say there's so much excitement generating here at SAM, where the three of us are meeting. I'm lucky to be copied on a lot of emails, so I get inklings that not everyone gets. And I knew that the target model was significant in terms of a step taken, but it's clear from this presentation that there's a strong leadership role that you all have undertaken in producing this. And I think AAC has to be, I hope everyone feels the pride and excitement I feel that we, in a sense, are part of a growing community in terms of linked art, and that this target model is evolving and could potentially be applied to all these other linked open data projects, including Pharos. I mean, it's very, very exciting, and I'm so deeply appreciative and excited about what you've presented today. And I'll be quiet now in case people have questions. I don't want to use up all the time, but we're just beaming here. Thank you, thank you.
Thank you.
I also have a lot of questions. It's Joan, but since you are part of the Getty and so am I, I'm going to pick your brain privately for both you and David.
Mm-hmm. Dwayne said on the chat, it'd be useful to briefly look at the linked art site. So here, this is the site. I hope you can see it. There's sort of only very skeletal bits about sort of community and so forth. Most of the work has gone into the model section. So there's sort of the background information about SciDoc CRM and the bits of CRM that we use. But then there's the shared patterns that we've talked about, so statements, partitioning, and classification. And then we go into more detail about the different sorts of objects. So for objects, there are the digital integration, rights, physical characteristics, provenance, and the core identity information. So just to look at core identity momentarily. For each of these sections, there will be a description of what is trying to be described. So the primary identifier for the object, where it goes, which is ID. And if you hover, then you'll see what that maps to in CRM or in the data. And then an example in JSON-LD of it in use. So here the URI of the resource is given an ID, here's ID, there's the URI of the resource. For other sorts of identifiers, there is a term is identified by, which we map into JSON-LD as identified by. Then each of those is an identifier, and they can have labels and values, and then again classifications with P2 has type, which we map to classified as. If you hover the AAT terms, you'll get the label for AAT, so you don't need to click through. So that's an accession number, this is the repository number. It's classified as a work of art, and it's classified as a painting.
When you link out and you get the label from AAT, is that the label that the Institute applied, that they chose from AAT, or the AAT preferred?
It's the AAT preferred label.
Even if it differs from the institution?
Because we don't know which institution, if any, is looking at the page at the time.
Okay.
I mean, if some of us here probably have been looking at the CDOC CRM and thinking about how to digest the CDOC CRM to do this on our own. This surely, I hope to see how much more practical this is what was presented today to use rather than the full complexity of the CDOC CRM. Anyone want to comment on that? What was that noise? Is that somebody to say something?
So just briefly,
Sorry.
people who are interested in which parts of CRM we use and why we have this sort of profile that goes through and explains, again, some of the design principles, but also there's an analysis of the classes and why we chose not to use them, or what we chose to use as being useful. So of about 100 classes, we use only 34.
This is Catherine at Princeton, and I have to echo Eleanor's comments. This is just really exciting, and you guys have done a tremendous job here in ways that I only barely knew you were working. but I think that this distillation of the CDOC CRM is something that really had to happen, and you've made a very clear distinction. I have one question, and that is, so for institutions like the British Museum who have published their collections in full-blown CDOC CRM, compliance, what needs to happen in order for their data to now be interoperable with data in this model? Will they have to sort of serialize their own data in this model for that to happen?
Yeah, that would be a very good first step. And thankfully, that is pretty straightforward, given the libraries and tools that are available for JSON-LD. So if there are triples in any format, then using the JSON-LD serializing tools, you can simply say, take this set of triples, use the linked dart context, and it will generate the serialization for you. So there's no sort of handcrafting of JSON required.
And actually, Mike, I think you guys have actually done this. Can you talk briefly about that?
Us guys, or?
Mike,
at the center, yeah, we did not just reserialize using the new context. We used the Sparkle construct query based on the one that you provided to transfer the data over. But it was a relatively straightforward process.
Yeah, Yale has their data published not using the serialization, but with very little work, you can convert from one form of linked data to another form of linked data. And that's how Yale's data, which is being contributed to the AAC, is actually coming through.
Yeah. And indeed, the site also has exactly this pattern. So you can get the JSON-LD. So let's look at took place at. You can get the raw JSON file. You can look at it in the JSON-LD playground, to play around with it, which I won't bother for it to load. But it also transforms it into Turtle and gives a more readable version of the Turtle where there's a little editor, and it'll update the view on the left-hand side as you change the strings. So it really, once you've got the information as triples, it's pretty easy to get to JSON-LD. And if you don't have the information as triples, it's probably easier to generate the JSON rather than the triples. And go from JSON-LD to triples rather than creating triples natively.
And that's an important point. It means that if you are an institution that has decent software developer support, but not excellent semantic support, you can go from your data to JSON, which a software developer is familiar with doing, and go from that JSON to the semantic data automatically. And if you're at an institution that is better with semantic technology, you can go from your content management system into triples or RDF natively, and then get out to JSON so developers can use it as in a form that they think is easy. And those support people coming from either side of that semantic web or web software development stack.
Rob, this is Ellen. Are we able to share the linked art now with people outside or not?
Yep, sure.
Okay. I just wanted to check first.
I have to, this is Joan again. I'm really blown away about the amount of work you guys have done on this and how complete it is. And I am so looking forward to applying it to things like Kona and to making the changes that need to happen in ULEN to make it easier to work with. So thank you again for including me in this conversation.
And for people who, if any of you go through this and think that there are aspects of your cataloging that we have not effectively covered, please let us know. We are working from our experience and from the data sets that we have, but the more content experts who say, this is really interesting, but I don't know how I would incorporate this aspect of our collection data, those are the sorts of questions that we really, really need and want.
Right. Makes sense. Okay, and Dwayne, do you have anything to add?
Not much more than, of course, this has been amazing work, and I've been following it possibly more closely than some, having been involved in various elements of it. But it's just, there's always so much more to see here than any of us realize, and it's just a tremendous amount of work. I think what will, one of the lessons that we've learned from the AAC work is that it's also important to be able to manifest this out in ways that people who aren't developers and data people can understand and see. So being able to bridge this through to the Browse app and through aspects of the review tool that David wrote last summer, I think is going to be really key to having a whole suite of tools that allow people to actually achieve what they want to achieve.
Right. And speaking of the review tool, I don't know if people have questions about the looking over the next 2 weeks to notify if there are any problems in what you are with your data. I don't know if you had any questions about that. I hope you can do that so that as the July meeting approaches, we have a good sense of what fixing we need to address. You can always email Dwayne and copy me after, today if you do have questions about it. But we're still working toward getting our data in as good a shape as possible by the end of this project, and these are all important steps toward that goal. And again, please recognize that this has been an incredible project from the onset, but particularly as it has evolved. Although there have been problems, these problems have led to important contributions, and we continue to play a leadership role. And with that, I think we had a good meeting today. Thank you all so much for participating.